yesterday. I don't know if you did. Where is your laptop?
เวลามา
You
แต่ที่เวลา
were
มัน
a good program. So did you try it? Oh, there was nothing, so you did it. Very nice. You can try it. So I want that we do it together. All right? We did it. Is it like this or like this? So let's do it together so that I think that if we do it together once, then we just start. So I have done a number of such exercises, but now sort of we can do it together slowly, step by step. And then once you're done with this, actually there is an assignment in the very beginning. Alright, so sort of that was question 1, that was a review, and then there is part 3 and 5. So 1 and 2 we did, essentially. So 3 and 4 I will do. Alright, so here, this is asymptotic limits. Maybe I will not do the derivation, but let you just review Uwe Hassler's slides or lecture notes. But we just remind you of what it is. When I changed this to row, it was row, I made it phi, so that I'm in line with the Uwe Hassler's lecture. And this is a simple Python programming stuff, so that is something which I will do with you. And I want to tell you a little bit of why TS statistic rejects when the null is wrong. Probably you know that, you have seen it, or you know that okay, it should reject. But now I will do it a little bit more, with more intuitions. So what is it? Why? How is it that it is actually rejecting when the null is wrong? And so on and so on. So that's the power function. So I want to tell you what the power is, essentially. You know, but I will redo it again. And I think it makes sense that I tell you what is p-value, because I don't like p-value.
Wait a while.
Thank you very much. Alright, so I will tell you what is p-value. Yeah, because yesterday I asked you and said, okay, we basically calculate the p-value and that's it, so we make a decision. But I think it makes sense to know what p-value is. And that's important to know. Because, I mean, the problem with p-value, well, I mean, recently I actually read a little article that some schools in Amsterdam actually started, well, universities started to ban the usage of p-values. And you shouldn't use them because they are so much misinterpreted. There are basically objects that are used so much everywhere in our discipline. But then they are also misused so much. And actually there are many statisticians that they say, hey, don't use p-values. That makes actually the analysis sometimes go wrong. And I think the reason is that in economics departments, one doesn't tell people what p-value is. You don't know what is p-value, a formal definition. And I want to tell you, right? I think it's important. I understood from asking you a few questions the other day. And once we are done with these 2 exercises, then I will move on and then do an exercise on forecasting. I know that you know what is forecasting, but I'm not sure if you have done any forecasting by yourself. Right? Give you some data and tell you, now go forecast the next year. So we'll do that too. All right? So sort of we will go, bring some real data from Fed, and then do some forecasting. With Python, with some basically packages that exist, and sort of I will tell you how to analyze sort of the forecasts. All right? So how to understand whether a model is good or not, what to do essentially when you have cycles and so on and so forth. Right? So that is something that I will do today. And then, well, this may take some time, these 3 topics. If I'm done with that, then it's good. Today, and then afterwards, then I will start looking at volatility models. Okay, so that's the plan. So let's start with this stuff, all right? So you said that you made some efforts, or if you look at it, maybe you didn't finish. That's not a problem. But I will start doing this. So one asset, and then the rest you do yours. Oh, we have two. Well, the air conditioning often works fine enough, but then thank you. All right, let's start. Well, I mean, the first thing I want to do with you is just to go and download this data. Right, so we put it somewhere on our hard drive, which is what I already have, and then you just read it. So if I know that yesterday I had a chat with Dr. Ha, and then he told me that very recently you had a Python programming class, so which is good. But then sort of there might be some little issues here and there when we work with data, so we just learn them maybe on top of what we have. One little step, very small. So that is the data, called data for CAPM, the data about CAPM. Let me just open it. And here we have well, a lot of the stuff. So I want to focus on S&P 500. So that is what we have, and that is the market index. There are daily, starting from January 2014. So that's 2, 3, 4, 5 is a weekend. Then we have 6, 7, 8, 9, 10. Then we have another weekend, and so on and so forth. Sort of the weekend markets are closed, and then we go up. So that's sort of why we have the days and stuff. And these are prices. They're not returns, but they're prices. But in CAPM, we need returns. We calculate returns. Now, maybe a very small question. How do you calculate returns of the prices? If I have prices of something, and I want the returns, then how do you do that? It's very simple. This is called the simple return, which is not good for econometrics because it's not additive. So let's say if I calculate daily returns over a week, and I want to calculate returns over so daily returns. Let's say I calculate them, and I want returns over a month. We are basically think of compounding, sort of unpacking this with 1 minus RT times 1 minus 1 plus RT minus 1, and so on and so forth. And subtract them, right? That's sort of how we use it. They're not additive. But then these are the simple returns. Right. But then in econometrics, we work with data that are additive. And let's say if I sort of have 1 apples, and you have 2 apples, and together we have 3. They are additive. You can add the numbers. And as such, so sort of for these type of moments that we work with, then we look at the log returns. Right? Times 1. So that is what we use. We don't use that. They're very close to each other. But I think for technical reasons, it makes sense to work with the log returns, not the simple returns. So that was this very question, a very simple question, but I wanted that you remind yourself of the additivity that we have here and the no additivity that we have. Just remember, trigonometrics will improve oftentimes. In practice, people care about this. They want to know, okay, so if I keep it one day, then what is the change in the price for yesterday? How much really going to happen in my life? Okay. So that was remarkable. But then, so if I want to do cap M, then I need a risk-free rate. Alright. So now I'm basically get a risk-free rate. This is the US market, S&P 500. That's the index on the US market. And as such, then we take a risk-free rate from the US market. We don't have it in this Excel sheet. Maybe I should have done it or downloaded it for you, but now we do. So now we basically go on and get the risk-free rate. And then you have everything, okay, so you have risk-free in one asset, and then it is the linear combination, so A plus B times the market X plus some short. So that's what happens. And then when we are asked you to look at sort of some of these, so what it does, NVIDIA, we can look at, and so on and so forth. So I just pick some randomly. I mean, sort of they are different in a sense, and we do the estimation of the CAPM beta using all of these sort of series, or maybe just to focus on one, and then using OLS, and also, well, you can use local linear or another Watson that so later. A local linear is interesting because we can get the derivative too. So that is the coefficient on the local linear in the function. We can do another Watson or the other one, so it doesn't matter. Alright, let's go. Let's go on with the program. So the first thing I will do is I want to read the data. So then I need, what do I need? I need handlers. It does not work. Now, well, I mean, we need actually to also connect to Fed. Alright, so to bring the risk-free rate. And then to do that, there is a package which is called Pandas Data Reader. Alright. So, well, that is a library that extends the capabilities of Pandas by providing easy access to various Pandas models. So let's see, what does it do? So that is how we install it. Right. And then we can always use it to connect to Fed. That's actually a very stable package that works very well with the Fed. The Fed data is freely available. We can of course open the page, get the data, download them, and so on and so forth. But then this is mechanized, that's very easy. And Fed doesn't have any restrictions, so you don't need to basically program any lapses, right? So sort of, there's a program that stops till the data or web injection reacts, that's very fast. There's no actually problem with that, so that's what we have. And it has a lot of interesting unique capabilities. I will tell you one, and then you do the rest. Whatever you need, and then you basically get it. And so on and so forth. So you need the API. I mean, we don't need the API here. Right? So we don't need any sort of, you know how to scratch a web page, right? Web scraping, you know. Suppose you have a page and you want to get the data out of it. Have you done that in the Python course? Alright, so it doesn't matter. So this Pandas data reader does it for us. So it goes, finds the Excel sheet, and then downloads it. If we didn't have it, then we would have programmed it ourselves. We would have gone, opened the page, found where the Excel is, and then get the link and download it. That's actually very simple, but this Pandas data reader does the work for us. Good, so now, I mean, if you don't have it, then you should install it. You should install Pandas data reader like so. So pick install Pandas minus is it an underline?
Yeah.
With the hyphen, with the minus.
Yes.
Excellent. All right. So that's how you install it. All right. So now that you have it, then you sort of say, right, from Atlas. And now when you want to read it, there is not a dash, but that's an underline. Well, that's natural because if it was a dash, then you would have thought that this is operator,
Từ nó chạy
operator.
đấy, nó đỏ, từ nó chạy,
And then we basically,
nó chạy. Cái bếp đó nó chạy.
alright. So here, so we need just data from this guy, and then we import it as them, just like the name, right? Because it connects to that.
Professor, can you zoom it in a bit? Yeah, thank you very much.
Let's import numpy as NP. There's another PHP. We will use SQL linear regressions. Then let's import stats models as SM, the API one. The API. And then let's import math.lib dot as PhD, so you can do some plotting or the functional forms that we get and so on and so forth, and then the linear regression. Let's fix our cParam figure dot per inch will be set to 600 so that the graphs look nice. And then we need the weights. Alright, so let's actually bring in the SciPy from the stats. We import norm, right? So that we have the normal PDF. That's our preference, right? So which we need for our analysis. Let's get the file, right? So let's say data. So data is on my laptop here. Backslash data underline the sheet name that we have, we want to get data from. And that's the S&P 500 daily. Copy. You're good? Alright, so let's basically get the data, just put it EF. We have 0 because we made it a little bit of fine tuning. And that's an Excel file. We read the data. Sheet name is sheet name. So that is what we have. Well, I mean the data actually have a what's the first column where dates are, right? So the index column is set to 0, and parse the dates. Right, so that's a parser. Right, so that sort of identify dates, if they are in text or in whatever format, and makes them real dates. Right. This is available with pandas. That's actually very strong. Wait, is it okay if I make it a bit smaller? Because like this. If you complain, alright, so let's see what does it do. When you take along, it's a big data. And you should not need it for. Right, so let's look at data for. Oh, so then there are two rows which we don't need. Right, so I'm just opening this end date or whatever we don't need it as something which is in that section. The second row we don't need. This last price we don't need. And the dates row we also don't need. So we have to remove them. But this row number 3 in index 2, right? It is the ticker name, so name of the asset, so that is what we need, and that should be the column names. The column names are ugly, we have to fix them. So we fix this. Alright. Let's carefully. So, well, and then the column names are here, right? So we're in this row. So that's row number 2, or 0, 1, 2.
3,
Then we can actually do the following.
2,
So we can get the columns first, and then maybe the F0. So we need just the second row. Alright, so that will be the columns. Let's look at it. Well, exactly. So these are all of the column names. Alright, so we have the indices. So these are the values we need. Alright. You know what is I log, and you know what is log. Right?
We have them now.
So you know what is I log.
Communication.
Yes. Exactly. Very good. So I log 2 is simply row number 2. Row as location, 0, 1, 2, and that is where we have the ticker names. So I connected them because I want to later be able to do an analysis of this data. This we do once because when we do other exercise later with volatility, then we will work with this data. The top we will take the out. So now let's look at again the data. So that's data frame, this number 0. Actually, so this is 0, 1, 2, 3, 4. From here onwards, then we have data. Then it means that that is number 5 till the end of the data frame that we need. The rest we don't. Right? So we keep only from 5 onwards. Alright? So what we do is that let's call it df, and then we df0. And then here we say I log again. So you know the index stuff, we start from 0 to d. I simplified that. So let's look at this. And then we have everything correct. These are the dates, and then we just need the column names to be fixed. Right? So let's say we say df dot column. So instead of equal to columns. And again we look at that. Oh, that's good. Alright, so far so good. So we are good to go. Well, this is called the start date. Let's call it date. Change the index name so that later when we do some stuff, it looks better. So here we say df dot index dot name. We set it to date. So that it looks a bit nice. Alright, so we have date. Now the data frame looks beautiful. And you can do work with it. So now, maybe a little bit of an issue. So here now go on and then fetch the data from Fed. Right? And then you have to merge these two data frames together. So we use merge. And we will merge on the dates. On the dates. These dates are the dates, 14th of January 2014. And there is a timestamp. That is not interesting when you want to do merging. So you have to always have either dates and times for both series or only dates. Right? So that is a problem we have to fix. Right? So we have to fix the dates. So take the time stamp off such that we really have dates because this is irrelevant. And then we would make problems when you want to merge data frames. Right? So later we will keep it in mind. Right? So far so good.
So, when we merge on the column of the time,
Exactly.
the date, not the time, we still eliminate the timestamp.
Sure. Well, timestamp we need to remove.
Okay.
Yeah, so, I mean, what I mean is the following. Now, let's say we have a date which is 2014, January 14th, say, and that row that we have here. And then with the timestamp. Alright, that's sort of what we do. This is the price data frame. Alright. Now let's say we get the risk-free rate. So if the date in the risk-free rate is 2014 January, but doesn't have a timestamp, then you will not be able to merge this. Because these two are different. They will not match. Alright. So as such you have to be careful. Make them normalized. Alright. For the timestamp we can remove. Here. So let's remove it. Let's remove it so that you know what I mean. So here, well, that's the data preparation we decide. So here we see the index of the data. So Pandas actually has something which is called toDate time. Alright, so that's a very nice function which converts argument to date time. So that's sort of what it does. It makes essentially a date time. So here we say, why do I say date time? It is df. So here we say, alright, so go get the index, change it to date time, and just keep the date. Yeah, so that's sort of the logic that we have here. We don't need the date and time, we just need the time. Sorry, the date.
Date.
Right. And let's look at df again. And look, I mean, the timestamp is gone.
Because before that, it's just a string, right? So you have to call and to make it date time and then eliminate, not just use it date time.
Well, I mean, the thing is that that's a very nice question. I really like your question. You're a hero of questioning. Here, when I did this, the parser, then it actually changes automatically the dates from text to dates in the index. That's the parser. But I read a little bit, maybe I'm overdoing it.
Yeah.
I'm overdoing it in the sense that sort of make sure that things are okay.
So if you bring out the parse data and you get do this thing again, it's still okay.
Yes. So it will, exactly, very nice. So it will actually, I mean, this parser is here. It's in there. I mean, explicitly I have it, but then, yeah, maybe things are not really working. Maybe there was some dash not missing somehow. Right? So then it will do it again and it makes it fine. Yeah. Very nice. Yeah, I like it. It's sort of, you have to be like you are. Alright, so then let's go on. So here we have the data. Now I will do another little thing here. That is overdoing it but making sure that things are really okay. Well look, so my laptop is German. Actually this is English. That is German. So in Germany, on German laptops, essentially, or German Windows, if you want to write 3 comma 5, then it is 3.5. How do you use it in Vietnam? That's point. Yeah. Moving this. This is children here. So you have it like so. So probably we don't need the step line to it. But then the thing is that so because you have here a comma, because they don't actually understand that this is a number. They think, oh, this is text. Then it makes or sort of some other stuff. For example, let's say you have an x which is 3 point, and then a dash, and then a 5. That's a single number. Right? That's 3.5. But then there is a dash, or sort of a space bar. Then it makes problems when you do sort of operations which work with numbers. Then we will fix this to sort of make sure that this doesn't happen. We have such a big data, so one can't check them all. So we always say, I do it always. It's a very fast step, and then it makes things work smooth. So this is what we will do. And then we say, all right, so let's go apply something which is called data to numeric. So that is the method which we will apply to the data. And then we say, all right, if there is an error, then shut down the error. We don't care. Okay, so you understood this step that I okay. So if there is some problem with the data, then this will remove it. So fix it so that everything that we have is numeric. So that's another thing that we need to do. And now that we are done with the data, alright, so here we'll explore this section data preparation step, preparation, and now we can define the returns. Well, this, I mean, there will be actually no problem, but then this will, try and accept. You will try. For example, let's say, so if you write, and x equals, say, log of minus 1, and you get an error. Right? But if you say try, this, accept, and then here you say print error. Right? And then your program will run. And you know the story. Right? So then let's say if I have other arguments. Right? So we will try to sort of add actually that is not a problem. Let's say we say 1 over y when y is 0. Okay? So that will not work. We get an error. Right? So if you sort of simply write this, then the program, the whole program will stop, will jump out. Right? But maybe that's not a very important error. Maybe, sometimes. Then if you want to basically say, alright, so let's look at the inverse of the data, and then whenever it is 0, that doesn't matter, just go on. Right? So it will just give you a message, hey, you have an error. The message you can do whatever you wish. So you will try this. If it works, then it works. It goes back. So it continues. If it doesn't work, then it brings an error and then continues. So that's actually a very nice little thing because well, oftentimes you have, when you write big programs, and then there may be some very not so important errors somewhere. So you can sort of jump over it, right? And let still the program work. And that was more or less the same. Right? So thank you. Alright, let's define them in returns. And the returns are NP log of df, these are all of the prices, times df with the shift 1 period back. So that's pt times pt minus 1. Let's drop the NAS. and then it's multiplied by 100, so then we have percentages. Yeah, so now we will have a new data frame which is new, and now it's going to have the first row which is a not, right? And then, well, we're good to go. Alright, so that's our return. Alright, so they look like this.
To some.
Yeah, oh, okay, so now, I see, so look, I mean, there are very few data points that are left. Alright. And I know the reason. Now let's look at the data. So that's the row data. We have these rows which we fixed and so on and so forth. But then, if I remember correctly, actually I stumbled on this some time ago. There are some series for which we don't have data. Let's look at the Excel. And I don't know, in some of these series, I can't now find it. Some of them, they don't have, I don't have data for. So these are data from Bloomberg. I think there were some elements which were added to S&P 500 or sort of some components after 2014. So they're pretty recent. The S&P 500 was, or sort of changes. Now and then, some new companies coming in, some leaving. So some have very few observations missing. Right? And now when I did so it means that those columns for which I have a non-available number should be actually, I don't need them. Before calculating the returns, that is what we have here. And then to do that, so here before, I would say that df is equal to df itself. And then here I would say drop nines over columns. Right? So that will be fixing the matter. You understood what I said? There are some of the series for which there is no price series for them, but there are few of them, and that is something which we want to avoid. And if I do that, so there are actually many. There are some data points left, sort of missing. So the df0 has, or the df itself, the df0 has 504. So these are the S&P 500 has 503 components, right? 1 500, there are 3 more. And so some of them they don't have, I don't have basically data for whatever reason when I downloaded them. Actually my assistant did the download some time ago from Bloomberg. And well, there are roughly 84. Right. I don't need to remove them, I don't need them. Right. But that doesn't matter for our purpose. We are not investing. We are learning. So now we have the returns in place. So for 419 series, the first one is the S&P 500. And then we can continue. So, well, let's look at the returns once more. So here there are indices, that's the series. We're starting from the 3rd of January, not 2nd. So because 2nd was not when we calculated the returns. Now we can go on and then obtain the risk-free rate. We haven't done anything. It's last half an hour or something that I'm doing. So I'm just telling you, or maybe reviewing some Python stuff. wait a moment, is it okay what I'm doing? You're benefiting from these discussions because they are not econometrics but they are Python. If you don't, then I will just move faster. Maybe post the stuff. So you are happy with this. So now let's go and then obtain the risk-free rate. So risk-free rate is on Fed. Alright, and then there is an Excel sheet. And when you want to download that, then you have to say a starting date and end date. Alright, so you need a beginning and an end. Alright, so that you can fetch the data. And at the beginning will be the beginning of the series. Alright, and then the end will be the end date that we have here. So let's maybe get the beginning and the end. So I would say I need the start date. Alright, and that will be essentially from the returns. These are the returns. We look at the index, which is the date, and then get the minimum. So that will be the start date. And then we do the maximum. And that will be the end date. So I have the beginning and the end. Alright. Now let's go get the risk-free rate. Alright, let's go with RF. And RF will be, so we have the web. Alright, so now this is web, that is tools for collecting data from sort of various remote sources. And then here we have a section which is called data reader. Right? So here is web that I brought from Pandas data reader that has a function which is called data reader. And it says, okay, what do you want? And then we say, okay, we need the daily given 3 months. Say, okay, the data source, I mean, I say none, but we don't need actually to fix it because the tickers of Fed are very unique. So they are very easily, they are not mixed with any other tickers. But otherwise, then you have to sort of fix the sort of source, right? So you say, all right, I want it from Google or Yahoo. But Yahoo you have to pay for. In January this year, then Yahoo is not free. Right? So you cannot download from Yahoo for free. Or if you have Bloomberg, well, then you need the API key, and then you say, all right, so Bloomberg has its own part. All right, so that is something which I will well, I don't need it, essentially. But then the ticker that we have is DB3, all right? To be non-ambiguous, then we sort of say the source is Fed, all right? And then we basically say, all right, so from the start date till the end date, which we have, the beginning of our sample till the end of the sample. Okay. So then it will get us the risk-free rate. This is Federal Reserve Board. Fred, not Fed, sorry. Alright, now I have the risk rate. Hoorah. So that is something which we have. So from 3rd of January, then 4th, 5th are weekends, and then we go on and on. Now and then there are still some numbers where, so 17 is a Friday, 18, 19 is a weekend, but for whatever reason we don't have the number in 20th, which is a Monday. Right? So we don't have the line. We use none. That's a problem, because the daily series, or sort of the series that we have are, I mean, from the returns, you need markets don't close. US. Right. So we have essentially those series. Now we have different approaches. So we have missing value problem. So now I go back to the question you had in the beginning. So when you have a missing value problem, what do you do? And So that's data science econometrics, right? So econometricians may actually think, so let's do a forecast using the previous basic data, and then we sort of give it once the forecast and then we plot it. We don't have it, but we can forecast.
Estimate.
Huh?
Some like estimate. Estimated value. I think somehow it's like estimated value.
Exactly. So you can estimate that
Yeah.
somehow, right? Or you can say, all right, so let's take an average of the previous days, all right? Or sort of the average of today and yesterday and tomorrow. You take an average and put it for today. Yeah? But maybe we can do the following, sort of think how Fed works. You know? So if there was a big change in the Fed rate, then it would have been announced. Right? So it means there was no change potential. There was no change. So well, it's 5 and then became 4. I mean, potentially they were deciding should we put it 4 or 5 on that day, and then so we don't have the series. But we are sure that on 21st of January it was 4. We don't know anything about 5. So maybe it makes sense to assume that it was indeed 5. Right? Yeah. Till a new change actually was announced. Maybe. Alright. So that's a logic that you come up with and then you agree with it. Right? And I don't know, maybe some economists or somebody from Fed may disagree. I don't know. Right? But that is something which seems plausible. Right? So what I will do is that whenever I have a none, then I will fill it with the previous value. If I have 2 nuns, these 2 nuns will be the same as the last value in the right? So I forward fill the data. Okay? So this is called forward fill. Okay? So now what we do is that we say this RF should be RF dot, well that's a pandas data frame, and then well, here we have a forward fill function. So you don't need to do it one by one, you rather use this forward fill and then you're good. So let's look at the data frame again. So 21st,
20.
what is it for? No, sorry, that was 20th. That was 20th, which is a Monday, and then it's forward fill. So the value which we had, the last value is filled here. So nines are removed, and we go on. Well, I know that these are stuff maybe very, as I said, they are not really econometrics, but I think they are important because oftentimes you face such problems whenever you work with real data. You have to deal with them somehow. You have to come up with logic and then you can move. So far, so good. Now that we are here, then you have to go and merge the data frames. Merge data frames. Let's call it merge data. Merge data, well, I guess you know what is merge. Yeah, you know. Right. Then you do the merging. You merge the returns with the risk-free rate, and then the left index return on. Right, so because we want to, yes, that is, this is the left, this is the right. Left, right. And then we do we restrict things to the left index. Right, so because that's an important one. They are the return series that we need. So we return it true. And then we sort of on how we merge, and we make it even. Right? Such that only those that are in common are sort of taken. Yeah, so you understand that. Very nice. So then we want that, then we have a merge data. And so let's look at the data frame again. Alright. Look, this also has a timestamp. Alright. Well, the previous one I removed, I didn't know, maybe risk-free rate doesn't have. I didn't know. So we have to also remove the timestamp here. Alright. and that is not a big deal. So we say, alright, so this RF dot index, then we basically do the PD dot to date and time. We have the RF dot index, and then we choose the date. Boom. Right index true, so we say, alright, so merge on the right index, then we also need the right index to also be on. Alright, so both indices should be on so that we can do the merging. Right, but that is how here, so that will be everything that we are doing. And now we work. Well, there are some discrepancies, or a few. There are 6 data points. Right, so which were not in common. Right, so we didn't have essentially the risk-free rate for whatever reason, so there was no match. And that is what we worked with. And indeed, so if the exercise that we have is not so sensitive, alright. So if I was to do that for maybe a more important setup, alright, then I would have become a little bit more careful with the dates. Alright. But here we don't actually have too much of differences, roughly 100 points out of 3,000. That's not so important for this regression that we want. That's not good. Alright, so far so good. Now we are ready to do our econometrics. That took a long time. So let's go on and then estimate now M using coordinates. Alright. Okay. So then we say on the S is equal to, so we need an X and a Y, right? So what is the X? Well, let's define some ticker. And let's say, well, because I need to basically collect the price of the returns of the specific asset. Let's see, let's go to the merge data, say. Well, this is hard to look for things here. Let's open the Excel. I'm sure I could do it in Python too, but let's say we start with what we want to analyze. Let's do NVIDIA. NVIDIA. Alright, so that's its ticker. So that's an unweighted, that's an equity. That is what we have here. So that's the ticker name. And continue going to Python. And saying, look, I want to extract this series from one. So we say go to the merge data, get the ticker, and now go to the merge data 2. So now I have to see what is the name of the data frame which we have as, so that's called DTB. Right, so from the merge data, then we go get DTB. So that's the risk free. That is Y. So that's the asset excess figure. Right. And now we need the X, which is merged data. Then I need a ticker for S&P 500 minus the risk free rate. That is the risk free rate. And then also, what is the name? It is called NSPX. And that is here. So that's SPX index. So S&P 500, that's the first one. So let's go there. And then have that. So that's the ticker, that's the Y, that's the X. Now we can do the rates. So then endogenous is this, exogenous
is set to actually we are not interested in testing. Yeah. We don't want to test whether capital beta is 1 or half or anything. But in any case, well, let's have this line out. Right? So you know that, right? So this option you know. That's the heteroscedasticity, so that's light item. Seven minutes. Then, so I have y, I have x, I have my ways. Let's print square sum. So I will show you the type, and then I will show you the data.
So I mean, this is in the matrix.
No, it's 4 lines.
No. We'll now move away from still another econometrics way, but then we need more data science. From mine. So y is the NVIDIA access return, and x is the market access. The data here. And you want to look at it.
Yeah, yeah.
So now look at one.
Yeah,
So-
it's really cool.
These are the can you look at the series of the here you are printing the returns. Doesn't work. Which one of it?
Okay, got it.
Maybe
Okay,
Okay.
So now let's look at the results, alright? So that's the kappa alpha, and that is B. And then what kappa beta is larger than the 1, which is what to be expected.
There is not a surprise with NVIDIA. NVIDIA, we know what is NVIDIA. Right? So that's a high tech. That's what it's from the tech industry. So, and that's turbulent. It reacts to sentiments. Sentiments, I mean news. So it goes up and down. A lot. And as such, the kappa beta is large. Now you have to keep in mind that this is a kappa beta that we discussed yesterday that potentially is not right because this kappa beta is not fixed. It sort of moves and goes up and down in time. But I mean, this data actually says, okay, so if you use all of the data points, then you get this kappa beta. What we can do, and so when we go a little bit ahead, is just to start estimating this using the stuff that we learned the other day, such that we can have this the beta actually being next to time. So to speak, we localize it in time. For every period, when we look at data around it, relevant to that. There's information which is in the future and also in the past. So now, going back to the question or discussion that you had with the other day, is that so maybe we shouldn't use future data points. So to speak, maybe we should look at data points which are sort of behind. So let's say if I'm today, then I look at the kappa beta in the past. So we look at a one-sided curve. So that may make more sense logically. What we do now is that I ignore this, I just told you. So you can do it in the sense that all the negatives are sort of all the future values, and then you set to 0 all the weights, and when you look at the past. But I mean, for now, there are weights. So essentially, we'll have the kernel, which at each point in time will basically localize on a certain value. And then we basically plot and then see how it looks like. So that's sort of what we want to do. So let's just start with estimation of kappa n. But let's do local linear. So that's sort of what we need. But we need a bandwidth. Right? Actually, for this data, I checked the bandwidth using local sort of this cross validation. And it should be a number right around 12, 13, 14, some number like so. Right? So you can check it as an exercise for yourself because it will take a lot of time. Right? I will set it to 12 and then you play around with it for now. Right? So that is what I do. And then I need sort of some containers to collect the alpha and beta both of them. Or so to speak, the m and the derivative. The derivative of the change in time of sort of well, let's go on. So here we have local in time, say m. Alright, so that is what we have. And local in time, beta is what we have. And then we also collect the dates. Alright, so local dates. Because if I want to plot them, then I will plot them for every point where I do an estimation, and I will have the dates. So the later we can do plotting very easily and neat. That is what we do. Now let's just start going. So here I'm looking for C. I'm just going to C0. T0 in a range of dates which are the length of our x variable. Now we start doing the sort of the analysis. So now because we want to do a local in time with the parabola, so the x-axis or the horizontal axis, the horizontal axis is time. Alright. So the input to the main thing escape is not
the x variable, rather that is the time. Yeah? So here we have the time in stretch. This is the first period, this is the last, and that's the horizontal axis. So this is actually what goes in the beta, not in x. I'm not localizing on x, we can't. We can do it like in the next step, we can do that. But now before we localize on t. I just want to know how beta changes in time. I don't want to know how beta changes depending on x. Not the asset, sort of the market premium, but rather the time. That's the first thing I want to know, because I want to know how beta changes over time. So then we need a stretch for the x-axis, let's call it t, and that will be a number range of level x. So that will be 0 to the n, lowercase. Alright, so that is what we have. Now we need the weights. Alright. And then weights will be the norm, PDF, alright, of, so here then we have t minus t0, so that will be the vector of analyzing, or sort of looking how far we are from the current point, so this is localization. Then we do obvious at t0, at any specific basic point, alright, and then we have the weights. So now that we have the weights, then we need to localize essentially our variable. Alright, so our basically x. Alright, so that's really important because I want to do a local in x. Indeed, so not only I'm actually fixed at time, but rather also on the x dimension. Let's then define an x local, and the x, because we want to let's do another what's maybe first. Let's do a local linear, that doesn't matter because we have alpha, beta, both of them. We have the constant and the slope coefficient both. Then, well here, let's do a data frame so that we have actually a very nice set. Alright, so out of the dictionary and we make a data frame. Let's call it x center because we have to center the x, remember, in the local linear, in the fashion of Taylor series expansion. And then we need our x minus, so here x I log of t0. So we are good to go. So that is what I have. So that's the localization in x for now that we have in and then what we do is going on with our estimation, right? So here we have a model which changes in the loop, right? So that will be stats models. We use the least squares as we did the other day. So that will be on x. And then here we need a constant, right? So Sm dot constant to x local. At x center. Is it clear what I'm doing? Let's make it a little smaller so that you see. Right, so here we do a weighted least squares, but you have to also pass the weights. Alright, so to this function. And then here we say that the weights are equal to the weights. And then we do a fit. Alright, so here we do the sampling. For the local linear. And then we run a regression of all of the bites. local hours and time. And now we can select everything that we need here. So here then, so let's call it alpha and beta, so that you remember that these are the constant and the slope that we have in the local linear setup. Now we can go on. We can say that the local in time alpha is equal to model dot not equal, but what do we need an appending? So we append to that, that's how it is. And here we say model dot params, and then we need the const. And so there we need alpha. Then we need the x center. And also we need let's call it beta. And then we also have the local date. And local date will be coming from, where does it come from? Well, it can come from x, it can come from y.
Beta.
Anywhere. Let's use x. So that will be index times 0. Where does it go? Beta plus 2. And then let's say we collect the results together in a data frame. Where we have the date, which is the local date. That's a dictionary. Then we have the alpha, which is the local in time alpha. Then we have the beta, which is the local in time beta. And then here we set the index, provided we can do that, to well, I mean, and that will be a new column, but it will also be set to be okay. So that is all of the details we need. So I again wait so that we finish your copy. And then afterwards we do it.
Have you run the for loop?
Not yet.
You can just say that that's not really range. You can just say range or in range.
Oh, sure. Yeah. Actually, I was thinking of a range, but then alright, thank you very much. So you did it already. It worked? Let me run it so that if there is a mistake, then I don't. And I start fixing rather than sitting here.
I have the same
Run PDF. So let's arrange. So let's look at T. made it an array. Good.
Yeah, yeah, I can see.
Okay, should we plot?
Well, every problem has a solution. We doesn't want the rain on the mid array, and the arrays always work. What are the data frames? I'm not sure. Let's plot, then we can compare our plots.
So, well, I need to plot, then I would like to plot the OLS value, alright? And also the, well, I mean, what we just estimated, right? So both of them. Alright. So let's just start. So here I would say T dot plot of let's look at the end results. So here dot index, so that will be the dates at which we did actually the estimation. And so here I will basically look at the end results of beta, which is the coefficient on the local x. Let's add a label. And the label is LA with H, which is H being 12. Good. Now we do another plot. We take a plot of, well, actually, I just want to add a horizontal line where I have the OLS. Right. So here then we can say we have along the axis, add a horizontal line across some axis. Right. So that is what I want. And so the value of it is OLS dot params. So this is equal to OLS. Yeah, that's the OLS. And then here we need params, but in the second location. So first, second, which is the exactly. So that's the OLS. This is the value. Then I'm using R log. And then go in the second, basically, location. Alright. Let's add a color. Let it be red. And then let's add a label, which is the OLS. So, DOT.legend. We do that and then we work into the brain. Boom. Hurrah. That's a nice one. I love it.
Thank you.
It makes actually a lot of sense. So when I do some estimation, then I'm always worried that the results that I get do not make sense. But this stuff.
So I just want to mention the one which you have on the LL, which is like the after that. Or as I'm not one, and you want to show that.
that I have here for adding a horizontal line is across an axis, then we need a horizontal line at the value of 1 equals this, right? Which is the kappa beta. I set the color and the label. Then we have this graph. Now this, 1 minute, then we go to our break. Look, kappa beta is a number which is above 1. That is what we have. And then kappa beta with this time localization is the blue one. Right? So, well, it does 2014 till here, then it is indeed rather around 1, sometimes it comes down, right? So it becomes very small. Sometimes again goes back to what we less actually see. And then from 2018 and so on, so then there is a big jump. Right? So, I mean, I think that around that time, if you read the history, then there was some boom, essentially, in their sort of movement, the volatility that they had, and then they went really up. And we have the COVID area, then they stayed essentially up. So around the COVID, then sort of there are also a lot of movement, so it came down, so markets were turbulent, so things were moving up and down a lot, then relax. So then for a long period of time, then it stays very high. Right? So that's actually this model seems to estimate the kappa beta too high. Right? Sort of 2.3, 2.5, and it goes to almost 4 at points in time. But I'm not surprised that it gets very large for NVIDIA at times this kappa beta. Maybe that is essentially a bit of overstatement because kappa beta of 4 is very large. But it indicates sort of these values indicate that NVIDIA has been problematic or very risky before, but it has become much more riskier compared to what it has been before, compared to about 10 years ago. So if I look at the OLS sort of estimate, and I see it's above 1, unfortunately, when it's standard,
Ở cái khúc OS giùm chị.
estimations. I understand the many
Có.
I know.
Cái OS phía trên đó.
So here you are basically getting the confirmation
Chị
of
bị
the
sai chỗ nào mà cái OS của chị bị sai. Ý là cái
that was a little exercise. We cannot do the
cái khúc đầu thôi, có nguyên khúc đó luôn, nguyên cái
some other
cái đoạn
more
đầu nha chị.
basically as we see that the company is slowly
Ừ, cái gì đó.
smaller. Any questions with respect to that? Right, but sort of maybe to summarize, this localized, basically local linear helps us understand the variation in this parameter first time. And that's pretty cheap. You know? We can do it differently too. Right, so now, in the second, basically, section of the class, I mean, we do this not with non-parametrics, but rather something else. So enjoy your break.
Gái lưu cái file Python cho chị xin lại.
Code Python của anh em đây. Nguyên cái không? Ừ, đưa file nó sẵn file thôi. Đưa vào anh lưu vào một cái điện thoại. Nó bị mất. Muốn luôn cái này là kêu 4 đi quá.
You can't rely on that.
Yeah, because they say that having is not like it's not worth every question.
Well, indeed, these models have merits, but they also have downsides, pros and cons. So, I mean, the fact that here we have to, and I didn't use an age which is a good age, just give you a number. Then you could tweak it a little bit on that, because that will affect essentially the capital alpha beta, both of them. but both will be essentially. So we should be a little bit careful. So that's one thing. The other basic thing is that maybe we should actually model this as a function of x. 2. So to speak that when x is high, then what happens to alpha? So let's say that we are in a condition when the x is low, very negative. So it means that we are losing. So what happens to alpha? Is it big or not? And then maybe we should choose this age a little bit more carefully. So that's the problem of the non-parametrics. And that's why I want to deal differently. So now when we do the second section, we do this alpha beta estimation in a little different way, which is fun. That will be a bit more reliable, but they will match to a great extent. Alpha is, yeah, I know, that's sort of a little problematic.
I realized that some funds, mutual funds in Vietnam, they show that in the website that rejects an alpha to show that they do better than the market term, the CAPM model.
One can learn that and then do the estimation. But it's interesting, how do they estimate? Is it the CAPM alpha, like doing OLS? Do they have factors? That's interesting.
Cái tên là cái tên được
Hết
dẫn.
nghĩa tiền. Ôi em ơi, sao con này tôi muốn chuyến rồi con, chị không muốn vậy. Rồi sao con đi có bằng chính.
Cái tên của anh có hành chính.
Đi tôi ra ta, cái xong.
Tại cái ta này nó là cái đường dẫn mà cái câu lệnh là đường dẫn với mẹ này có chép cốt mà không để ý. Nó là cái đường dài thì nó nhìn chữ.
Rồi bác đi hay gì đi, cái tại vì ra ta cái xong nó biết. Không biết là thành phố à. Có rồi là thành phố bảo không? Định với gì? Là máy có lẽ. Nó có này đâu. Có đây luôn. Cho nên đâm túi thì có cái này chứ. Hiện tại không? Bà muốn còn tới bên tôi không? Hả? Bà muốn ngồi đây. Mà cái còn một chỗ nữa. Trời ơi, nhiệt tình. Được chào mời quá trời luôn.
Rồi anh đi qua đây luôn. Cho anh đi xuống dưới luôn. Cho còn mọi người. Thế là đợi thầy định bên thôi thì đợi chị tôi định lại.
Ví dụ như em làm này cho anh.
Mà muốn ở đây thì tôi sẽ lên chở anh về, không thì tôi sẽ ngồi chỗ anh cũng được.
Đó thôi cho tôi mặc chỗ này. Là tôi coi phim nhưng mà mình bị sợ.
Nhưng mà đâu đi đâu bạn? Không tái mà đâu đi tốt.
Như thay vì anh tính trung bình cuối 4 cái, còn đây là tính trung bình tất cả các năm luôn chứ. Còn cái kia là tính trung bình khúc đó nó đi qua tới 6 tháng, nhưng mà nói chung là nó chỉ chia ra từ nhiều khúc thôi, như là nó chia nhiều cái kinh nghiệm thôi. Tức là cái lợi nhuận nó sẽ từ hàng cái. Em cũng không biết chắc là vậy, nó không có thể chia ra. Em cũng không biết cái đó là sự nó chia cái hát, nhưng mà em không biết chia ra như vậy là sao.
Ủa anh mấy cái này sẽ gặp được muốn.
Không biết.
Mày đúng là mình sẽ hai cái bài nào mà nó có câu kêu la như này kêu
phải là cái 12 là
Kiểu tóc
cứ
liền.
12 cái
không phải là linearize, nó đi vào cái
Đi qua đây ngồi đúng không? Cái thấy anh ở ngoài rồi đó. Anh ngồi một chỗ với chỗ bên về.
và là
có nghĩa là thay vì mình xét hết dữ liệu của
để
nó
làm thì mình
chia
Qua luôn
vẽ cái
chia
đường
họ bắt
chia
cái
chia
lên đó.
vẽ cái đường tiếp đi liên tục vẽ cái đường
Không vô ăn nữa.
để ra chơi vô luôn ngồi.
Anh đi qua đây gọi luôn.
không cho đi ngoài bộ cái thư lên đây ngồi hả
Cái lý anh rồi đây.
Lên ngồi gió anh. Anh ngồi đó để xu đó mà.
đi ngồi giữa mà
Đây này.
Rồi tôi sợ rồi tôi nghe bị cười quá. Mấy để còn hát nữa rồi. Để còn hát.
không nghe
Có tiền, tí vô
sợ
tiền.
mê
Tí
quá
cái con của anh hát.
giận rồi sao giờ này tôi nổi gì lên đúng trời
Gì?
trên mắt là tự nhiên
Cái nước rồi.
cái gì vậy
Rồi như là bị cái cứng cứng.
cái thứ muốn không gì nghe nặng mòn sợ muốn bao quá sớm giờ nó mũi ngắt
Nó sáng tôi cũng ăn bánh bao. Xong rồi tôi cho con mẹ tôi đi cùng cái vui. Đấy, ổn.
ủa sao nó căng quá vậy nó căng mà nó đang bị kẹt rồi bạn đang hơi căng rồi bà để lên mà nó
Các bạn nhấc cái ghế lên.
Ôi trời ơi. Để cho thầy này có viết cái bên bển nữa. Để viết một bên thôi. Để viết bển đâu ai thấy đâu.
Cô bệnh tôi cô bệnh lại không thấy.
Đó trên thầy bỏ cặp bỏ đâu ra.
Để vào đây rồi.
Xin cho tiền cái ghế ngồi đi nhìn đã.
Rồi cặp xích chứ. Có nào rồi đó.
Trên cái hả?
Bỏ cái đáy mà.
anh đi cái này nè
Quay cho nó.
Quay cho đi.
Có cái đồ quay á.
Vô vậy?
Đúng không?
nó cao thấp lửa nó cao thấp lên được mà
Sao vậy? Bàn à, lôi ra ngoài.
Ủa vậy sao bạn? Sao không các bạn không có được? À,
Rồi đi tìm cái này lên xuống. Quay
Ủa,
hoài.
vậy thầy cho nghĩ là mấy phút à?
Cắt đúng không?
Có nó xuống ở đây xuống á.
Wow. Thế giới này phát triển quá vậy đó.
Chưa bằng chưa.
bây giờ đó mình cũng có xác nhận luôn
Các nhỏ.
Đúng rồi. Cái nhập tỉnh nè.
nó nhập gặp luôn còn những hiếu rồi cho hiếu đây mà
Không, anh qua đây là không chỗ với anh nội bỏng rồi.
hôm bữa Diệu Quân nó chui đúng không nó chui người anh luôn á
Đi tôi. Hôm qua cũng vậy rồi. Tôi với bà Tiền tự
nó
nhiên
nói
thấy
hát
dài.
không phải hát nó là bạn nước hát nhỏ hát nhỏ thì hát nhỏ thì nhìn gần gần hát lớn thì nhìn xa xa luôn á nó rải ra không phải cái chuyện nhỏ
Cái này đâu có hát lớn đâu.
hát 12 lần đó anh
À cái số
hát nhỏ mà chắc là cái gì nè dễ hiểu mà còn ra cái bản đồ này cái đồ này vẽ nó
Không chị ơi, có những cái vấn đề.
cái lệnh mình cũng
Dạ,
vẽ
kiểu.
nó
Cái này thì
sẽ phải đại lúc mà hát nhỏ nhỏ như vậy thôi nó
Có phải
biến mà đề tài còn là cái góc này
số lạ lắm.
xong rồi
Nhiều cái không
xếp
biết
lại
giải.
Bạn nào thì thấy dễ hả?
cái này và xong rồi qua cái này nó xuống lại sao nó có thể là âm luôn có thể là đi xuống là hồng đó kiểu lại thì có nghĩa là cái hát mà nó nhỏ như là cái điệu nổ của đây nè hát mà nhỏ là siêu siêu nét luôn nghĩa là siêu để
Các bạn
là cái đại
các bạn
siêu nhỏ là bạn
nha, các bạn
thì nó sẽ cái tiếng bắt thì cái để cái tiếng là cái khi hát nó lớn mà thấy dễ này thì đôi khi tìm nó ra cái tiếng cái vùng này để tìm nghe theo cái tiếng là gì tại vì tiếng con ta lại cái nó tỷ lệ với lại cái thị trường tỷ lệ này nó chỉ vẽ data thôi cho nên là nó hơi khó đi nhưng mà nó chỉ đang vẽ data thôi thì tại vì mình chỉ cần quan tâm data thôi thì phải nói này có lúc này nó ít rủi ro hơn thị trường lúc này, nhưng mà sau này nó rủi ro hơn thị trường, nó gấp 4 lần thị trường bây giờ. Cái này Nvidia dạ đúng không? Các em bây giờ các em có gì cần xét về cái test này nè. Giờ đi tìm RF bạn beta cái này đúng rồi.
Cái bàn thì nó đã quá không á, cho mua một cái gì có tiền.
Thầy vẽ thêm cái màu này lót là thầy vẽ cái màu xanh, sau đó thầy vẽ thêm cái màu đỏ chèn lên. Có nhiều câu lệnh để vẽ thêm cái đó lắm, mà thầy chọn mấy cái câu lệnh này.
Thầy chọn hả?
Thầy biết nhiều câu lệnh.
Thấy thầy với cô
Học thầy Hà xong học thầy này như là bầu trời khác vậy, không chết GPT luôn.
thầy không viết sai luôn.
Biết cái sổ luôn.
Đúng rồi. Ít trên internet luôn, còn gì là cứ đọc thôi, bấm siêu nhanh thôi.
Có một cái đường trong đầu phải có chuyện rồi điện nó lại. Có gì á, chí thức có phải
Mà đâu có
chuyện
yên
nào
vọng
mình
đâu.
mình cái
From thành vào
hay uống được gì mà đừng wifi, nó hay ngu quá rồi. Không ai có thể cứu được. Coi nó
thấy ghê không?
dân đầu.
Nói mấy tiếng đồng hồ luôn.
Thì hôm qua nhà cũng có sự biết luôn. Tưởng giả không á. Quá đi.
Tất cả là bạn không biết được.
Phải không?
Sao kêu không cả này?
Thì mình chở cái nhiều đấy với anh nào.
Nếu mà đó mình có làm mấy bạn mới phát nhập ở bên này à.
Em bỏ tiền nó kêu.
Cái anh nó ở đây. Cái anh muốn ở đây, em lên thì ngồi. Chị không muốn ngồi với anh
Thì
nữa.
đúng rồi với em.
Đúng rồi, rồi xong bắt cái đội. Là nên nhớ cái gương mặt này.
Ở chứa bạn thì luôn á.
Đừng có ngồi dậy. Đúng rồi, ngồi đây lúc mà thấy mình sợ thấy một cái
Ý là nó có cái
phản chiếu lại.
Có những cái đó gì hơn. Có nên là thầy dễ hơn.
Mắc gì cái độ tiếng Minh Thư.
ý là cái đồ là tiếng giống em hơn chứ không có dám thầy của em hơn á.
Trời ơi, phạ một người gấp cái này chắc
Ủa nó chơi đi chứ sao đâu. Nó nói là
So you always have your food with you. You bring from home.
I bought it outside so that I can get some time because it's so far away.
That's very good.
có bằng mình đi không?
Có.
Để những không mình cái gia đình này nó xấu rồi.
Quán nào cũng
Ba đi nó xấu không?
ba người nó em luôn.
Rồi rồi.
Mấy có trâu gà nữa đó, loại lửa hùng ra.
Chưa chắc mà có đứa ở trúng bão không có trúng mưa.
Nhưng mà hồ là con mà
Nó hết từ lâu rồi, nó báo rồi, nó hết biên giới từ lâu rồi.
Đông vui quá. Quá đông vui luôn.